In this video, this is our continuation or discussion of the file system. So in this video, we will focus on file system analysis. So remember, this is a continuation of our discussion for the week of March 23rd. So this would be the lecture for March 25th, 2020 in the course ITS 372, System Administration. Right, so Sys Admin. And I'm Professor Calix. Okay, so if you remember in the previous video in the sequence, we looked at, a discussion. We had a discussion of the file system itself. In this video, we're going to extend that and look at file system analysis. So the idea is some of the concepts when you want to look at the file system as an entire unit. So you want to remember that the file system is that hierarchical tree structure, okay, of, we talked about all of this last week, or this week rather, on Monday. And so here, our idea is that we're going to look at the file system as an entire unit, and then we're going to inspect it, do an analysis of some type. And so what are some of the issues involved in that? So remember that previously we talked about all the different folders, and now we're going to move on to file system analysis. So as a reminder, so I should say that this discussion will lead up to the lab that will be assigned this week. So remember, you have a lab assignment for the topic of file system analysis. And so after these slides, I will start describing the lab that you are responsible for, and we will talk a little bit about when this lab will be due. So as a reminder, remember that in UNIX, so remember in UNIX, all files, all user accessible files, so let's say all user, so this is kind of like a reminder, okay, reminder, all user accessible files are organized into a single hierarchical directory structure. Right? And this is the main concept that we discussed, right? So remember in the previous lecture, we talked about how there was really with the file system just one single idea. And this is the essence of that idea. So it's, it's important to think of that. All user accessible files are organized into a single hierarchical directory structure. And the files and directories, it contains, in the file system. So the files and directories in the file system, may be spread across several different disk drives. So may be spread across several disk drives. Okay, and so this will be actually the objective of this lab, right? So the idea is that we're going to have 2 disk drives for this lab, and then you're going to try to link them somehow into a single file system. Okay, so that will take us into our lab. So, and the files and directories in the file system may be spread across several disk drives. All right, so based basically we will have to talk about a few concepts, and in particular we'll talk about the concept of mounting a disk or a partition. So this is really the main concept. So this translates into specific commands such as the mount command or the unmount command. All right, so that's what whenever we talk about a concept in Linux, as I've always said, it's always associated with some specific command. So in this case, this will be associated with the mount command. So in this case, mounting in Unix, mounting a disk refers to the process of making the device's contents available. All right, so we have a specific hierarchical tree, and then we have another one, and this hierarchical tree is in a partition or a disk, and so we need to have an attaching point, and then we're going to mount it so that now both of these disks are part of the same file system. So Unix in this case will attach the files, so these individual files in this disk, to a specific location in the file system of this other computer. So from D1 to D2. All right, so as an example of this, the notation for using the mount command. So let's think about this as the mount command. The mount command. All right, so let's say that we have a disk. So here we have a disk, and it's called, we have it in dev, disk 1. All right, so something like that. So this is, by definition, this is the disk partition. This is the disk partition to be mounted. Okay, so this is the disk partition to be mounted. We have that here, some data is in here. And then we have a tree, right? So we have a tree, and it's got like user, and it's got bin. And then we have another folder, actually over here. Let's call it home. Okay, so basically this is another computer. This is computer 1, this is computer 2, for instance, or, different disks. And so what we want to do is we want to specify that this home over here will be the location where to mount. Or actually instead of the location, let's just briefly just say the mount point. So that's the mount point. So basically, if we want to do this, then all we have to do on the command line is, imagine you have a root terminal, and you're going to type mount, and then you mount dev disk 1, right? And you're going to mount that into root home. Remember that this is the root folder right there. And so this would be our command to run on the terminal. So that's an example of the usage of the mount command itself. So let's move on to the next slide. Right, so after we do that previous step of mounting disk 1 into the file system, this disk partition will now appear as part of so this disk partition here will appear as part of the file tree, this file tree, where it has been mounted, specifically at this mount point. So that's what I just described, in essence, is what you will do in your lab. Okay, so this is what you will do in your lab. Now, your lab, we will basically, let me describe the lab here, give you the motivation. We're going to assume the concept of forensics. All right, so this is not a forensics class per se, but we're going to motivate our problem based on this idea. So imagine that you have two computers. computer 1 and then computer 2. And then this computer has been compromised. So this computer has been compromised. And so now you have a law enforcement and they have a forensics computer and they want to analyze. They want to take a look at the data in here. So imagine they have like a little detectives, it doesn't look like a great eyeglass, but anyway. So they want to inspect, right? So they want to inspect this computer. And so what you want to do is you want to take this computer and all its functionality. You have a file system over here, and then you want to attach to this file system that computer. However, there are several problems to be addressed. In particular, the computers are actually, in a LAN maybe, in the network. So you have one node here in the LAN, the network, and then you have another one. And so you need to move the data across the network, right? So we need to move the data across the network, and we want to copy everything. We don't just want to like copy the files individually, but instead we want to copy the entire partition. So we want to copy, our goal is to copy the whole partition. Okay, with all information, even information that may have been deleted. As you know, when something gets deleted, you have a file name and you have the data here. Deletion doesn't mean that this data here gets deleted. It just means that the link is broken, right? But the data remains. And so we want to copy the whole partition. So we're going to explore how that can be done. Okay, so this is the scenario of our lab. And as I said, it's going to be motivated by the idea of forensics. So I should say that to copy the whole partition, we're going to use the Linux dd command. Okay, so we will use that one for that purpose. Additionally, whenever we're in a computer, let's say we're in this computer or that computer, and we want to look at the information of the file system or the disk partitions, remember that we learned in a previous lab that we can type df-h. So that's one of the commands that is available as well. All right, so here we've sort of described the problem. As I said, the problem is, we have a compromised computer, we have a forensics computer, and we want to copy the data, but we don't just want to copy the individual files. Our goal is to copy the whole partition, okay? And so we're going to use the dd command. Additionally, we have the other issue that, we bring in the forensic computer here and the compromised computer here, and we need to, actually this should be backwards. So this is the and this is the forensics. We want to move the data, and we're going to explore how we can move the data securely. So there's the issue that, you might be moving the data across multiple networks that you don't trust. And so in that case, can you send the data, more securely with confidentiality, right? So to achieve confidentiality, we can use cryptography. And so we're going to explore all of these ideas in this problem. Okay, let's move on to the next slide. All right, so the first thing is I talked about, in the previous slide, I talked about the dd command, right? So I talked about that command. So now I'm going to just provide a simple definition in Linux. So in Unix, we have this command available. And it's basically for, dd is for copying. dd is for copying individual disk partitions or disks, okay? So another way of looking at it is that this command dd creates, so let's say this creates a bit for bit. So this creates a bit for bit identical copy. Of each file system. Okay, so think about it, of each file system. So this basically copies everything. Okay, so this will copy everything. The dd command in Unix is for copying individual disk partitions, and this creates a bit for bit identical copy of each file system, of the entire partition. And this includes everything, so including, includes deleted files or file data and other metadata. And as you might imagine, for somebody that's interested in forensics and things like that, all information could be relevant and useful. Okay. So now that we've talked about this, you talked about the main idea of the lab, the main problem, we're going to go directly to the lab itself and explore all the aspects that are required, right? So I'm going to move from here. I'm going to move to the handout that I have available. So let's move on. Let me. So I'm going to move on to the document. And just before I move on to the document, let me just actually, I like to bring up the calendar just to make sure we're clear on everything. So this lecture that I'm currently recording, this video that I'm currently recording, will appear on this box, March 25th. So file system analysis in grep and awk. So if you remember, these are the assignments that you're working on for this week. All right, so I provided 2 videos last Monday on March 23rd, and the video that I'm currently recording will be posted here and just relates to the lab itself. Okay, I've already described grep and awk. Remember that the grep and awk lab is already posted. You can find in the PowerPoint slides, you can find the information on the problem that you need to solve. But anyway, that was just an aside. So for this, right now, this lab that I'm about to describe relates to the file system analysis and how you can do it. Okay, another thing I wanted to mention is that you will need 2 VMs for this. And I think I mentioned this already, right? And I want to reiterate it actually by going back to the slides. If you remember, one important issue with this is that you are copying everything from one computer to another computer. And so you want to make sure that this computer has enough space. So basically, space is an issue here. All right, space. So what I would recommend is, let's say you have a VM that is 19 gigabytes in size, and you're using up about, some, but you have available about 12. So 7 is used, and then available. Oops, that looks terrible. Available. Let me start over. Okay, so available data. All right, so make sure that this VM is smaller, all right? Because if you start the DD process, and this is bigger than the amount of space you have here, you could end up bricking the VM, and then you're going to ruin everything. Okay, so with this lab, it requires you to move quite a bit of information across your environment, so make sure that you address this. The way to know how much space you have available is df, -h. You can run that command on both computers. Make sure you know the size of the partitions that you're moving. So in this case, you want to make sure that the partition that you're moving here, from this side to that side is less than 12. So, let's say like 9 gigabytes or less should be less than 9 gigabytes, right? So that's the maximum that you want to have there. So just, remember that as that's an important issue. one suggestion, if we go to the website, one suggestion I would make is that you might want to take a look at the seed environment. So I know I've provided this 1604 VM, so you can try that one to look at the size of it. That might be important. But if you go to the Seed Labs environment, you will also find that there are two VMs here. There's the 1604, and then there's an older version, 1204. Okay, so the 1204, although it doesn't specify here, I believe it's smaller. All right, so you might want to check both 1604 and 1204 and see if 1204 will fit in 1604 or in the other 1604 that I described. So this is something that I leave to you to figure out. You should be able to find a way, but the key element is that you're copying a disk drive from here into here. You have to make sure it fits, okay? All right, so now that I've mentioned that, we can go back on here. Additionally, I wanted to stress something else about the website. So in the website, I haven't done so yet, but very soon I'm going to be adding a section in here called code, and it'll be a GitHub section, it'll have a link to GitHub. So I've posted on GitHub some of the scripts that we've done in the class this semester. And so I think I've gotten some requests for the code, so I think that's a good way. So whenever we do scripting, I will try to upload the scripts to remember, these are not going to be the finished scripts. They're only going to be the in-class demos so that you get what I would do on the demo. And then obviously, usually you have to finish those scripts and make them, for your homework assignments. All right, anyway, so that was just a suggestion with regards to the file system analysis lab. You can take a look at those two VMs, but it's very important that you make sure that things will fit. All right, so now let's go on. So if you go to Blackboard, remember you will have to go to Blackboard to download this document. This document will be under File System Analysis. All right, so this document will be under the File System Analysis in Blackboard. So make sure you take a look at it. Let me change the thickness of this. It's a little bit better. All right, so so for your lab for March 25th, go to Blackboard and download this document. You can see it here. It's File System Analysis. And you will follow all the different information in this lab, okay, to complete it. So let's start. So I'll explain. I mean, it's pretty self-explanatory. You can just read through it, but I'm just going to make a few suggestions here. So let's see. All right, so without going into all the details, because you can read through it, as I said, the goal is to use the dd command to move the partition from one VM to another through the network. Okay, so you have to do that. So there's a few ideas in there. So the first one is that you're going to, check, you can use these commands, df and df-h. These will allow you to check the folders and check for space available. After that, you're going to, in this lab, you're going to be practicing with the commands mount and unmount. So I suggest you read, these descriptions here. But these commands will allow you to be able, basically, once you have an image, you've copied it from one machine to the other, that you'll be able to take that image and mount it to the file system, right? So let's look at the first part. Let's focus on bullet, on this section here. So from 13 on. So one of the key commands that you're going to learn about in this lab is a very nice command called netcat. Netcat is a really nice tool that allows you to basically redirect information between machines. And so we will be using it for our purposes. Okay. So here we will be using netcat as well. So let's look at the first example. So this is really, you can read through the rest, but this is really what I wanted to explain here. All right, so imagine that we have two machines, right? So we have one machine, and for the other one, I'm just gonna make it smaller to kind of indicate that that's the smaller one. So we're copying this partition from this machine to that machine, right? So across the network. This is one VM, let's say, and this is another VM. So for instance, I'm gonna say, just for this example, that this is Ubuntu 12.04, and then this is 16.04. Right? So I'm saying that. And I'm going to send this information across the network. First, I'm going to send this information unencrypted. All right, so you can see here I'm following this. So what you need to do first is you need to go to this machine, actually, sorry, you need to go to this machine, the receiving machine, and you need to open a port. So on this machine, you're going to open a port, and then that port will receive information that goes into a file. Okay, so that's what you're doing with this command. So on the receiving machine, 1604 in this case, for my example, you're going to use netcat, and then you're going to specify a port 1234. So that just means that this machine is listening on port 1234. So any data that comes in through 1234, you remember this is a redirection symbol and will be redirected to victim.sda1. That will be the name of the file. All right, so the file is going to be called victim.sda1. Okay. Another thing you can do is, so once you've done that, then the next step is that you're going to go to the, you can see that here, you're going to go to the sending machine, which in this case is 1204 for my example, because this is what we're copying, right? We're copying this disk partition and sending it to this one. So in that case, in that machine, so on the sender, 1204 for my example here, you're going to run the dd command. You specify the dd command and you tell it to grab dev sda1. So this would be the partition in this machine that you're copying. Okay, so you're going to have to match the name of the thing you're trying to copy. And then you grab that, and notice here we have the pipe, which means redirection. So we redirected into this command, which is another netcat. So another netcat command. And in this case, this command, basically, remember, you're running this whole command 26 on this machine, right, on 1204. So you're going to open a netcat, and that netcat will go to the receiving host. So notice now that you're basically opening a channel. I'll erase this, and you're now opening a channel, right, to the receiving host. So this will be the IP or the host name, either one, of the receiving host, and then you specify what port you're using, 1234, which by the way is the port that we had designated over here. So you can see that that's the case. Let me close the website. Okay, so that's basically how it works for you to, you need two commands. You need two commands to launch, to basically to copy the information if you're using the unencrypted approach. And you can see a little diagram here. So basically we have our disk partition through netcat. We send it to port 1234 of the netcat server, right? So the receiving machine, and then that creates our image file, right, that we described previously. All right, now another way of doing this is to use an encrypted approach. So in an encrypted approach, you actually end up needing 3 commands. You can see that here. Here are the 3 commands. Okay, so you need this one, you need that one, and you need this one. Okay, so I will describe these. Hopefully, if I can fit the diagram here. They're very similar to the previous example, but so think about it. For bullet 33, so here, this command 33 will be done on the receiving machine. So the receiving machine will be this one, right? So the receiving machine will be that one over there. Okay, so let's go ahead and explore that command. So that's the same one. We do netcat on port 1234. So that basically means that we open port 1234 on this machine, and any data that comes here is going to be sent to create the file victim.sda1. So this will be victim.sda1. Okay, so that will be victim.sda1. So that's that bullet number 33. The next command is this one. We have to create the tunnel, right? So we have to create a secure tunnel, because remember that we're using an encrypted approach, which basically means we're going to use the SSH command. Okay, so we established SSH. So in okay, so we're going to go over here and we're going to specify we're going to connect to the sender. If you notice here, we're going to go to the machine. We're going to go to in a different terminal window, still in the victim. Remember, the victim is this one, or rather, it's no, this is the victim. So we ran the sending host. Yeah, so we need to run this command. I'm just double checking. So it's going to be on the receiving host again. So we're going to make this tunnel. So I'll repeat this just so it's clear. So this is the receive, and this is the sender. So let's use that designation, receive it. All right, so on the receiving end, first thing we do is we open netcat. We open port 1234, that one. All right, and any data that we receive there will be redirected to victim.sda1, which will be this image file here. Then still on the receiver, still here, you will open a second terminal. So you need to open a second terminal, and in that second terminal you will run this command, which basically means that now, if you notice, you're going to run SSH. You specify the user and the IP of the sender, so it's got to be the IP of this one. All right, so you're going to specify that IP, and you create the SSH tunnel between. So you create basically a little tunnel, but you're initiating it from this machine. Okay, so you initiate it from the receiver. That's where you run that command. So let me just say here, you run the netcat, and then also the SSH, and then on this other side, you're going to run the DD command. All right, so that should be clearer. All right, so once you run this command, SSH, IP sender, which is this one, right, and the seed, then you specify where it should go, right? So you're saying here that you're going to open port, you're going to redirect your connection to port 2345. So basically this end is port 2345. We already know that this end is 1234, so you can see that because we opened that port 1234. So that is indicated here. So we say basically that the tunnel is from IP sender, which is this one, to localhost, which is this one. So there you have to specify the IP addresses or host names. And then we say that the tunnel starts at port 2345, that one, and it ends at 1234, that one. Okay, so that's really how that works. Once you've established the tunnel, the last part is pretty much the same thing that we did before. For the unencrypted version, you're just going to go to, the sender, this side, right? So the sender here, and you're going to type the DD command, right? If you notice here that you do DD, you specify the partition that you're sending, you redirect, and then you use netcat, and you basically say localhost, which because you're running on this side, it means this computer, right? So you do localhost, and you specify that the data should be forwarded to 2345. Guess what? 23345 is the start of the tunnel on this side. Okay, so on this side of the network. All right, so that's basically what those three commands do. They basically open a tunnel, an SSH tunnel, and then it allows you with DD to copy the information from this side, and send it over there to that file. Okay, so that's really the lab. It's not really that complex. Once you've finished transferring the data, so once you finish transferring the data, let's say that now you had, let's say, the victim, and then the forensic machine, and you've done the DD command, right? So you did DD and you transfer the data. Keep in mind that DD command will take a while to copy all that information. Okay, it's a lot of data, so it will take a while. But anyway, so once you've completed that, and then now you're done with the victim, right? You don't need it anymore, and now you can just focus on the forensic side, or the machine. This machine now within it has victim, that file victim.sda1 now exists on this machine, right? Because that's where it ended up. That partition was copied through the DD command. So now what you have to do, if you remember, we talked about it, this forensic machine has a file system. So it has something like user, and it has bin, and it probably, etc., right? And different things. So what you want to do now is you want to mount victim SDA1, and you want to mount it onto a specific point in the file system. All right, and so that's what you're going to do. So you're going to create a folder. All right, so you can see that here in bullet number 46, mkdir victim. So you create victim as a node in your tree, and then you're going to read all these instructions, but basically you follow this command, number 56, which allows you to mount victim into that specific side of the folder. Okay, so I do suggest there's a little bit more to it. Read through it. It's very interesting things about how files can be hidden, etc. So read all the points. But that's the main concept of the lab. All right. If you're successful, then you will end up with, imagine this was victim SDA1, and now it will be mounted in the file system. So now you can access the information. So you should be able to, as read-only maybe, access the information and actually do a little bit of forensics on it, individually as well. So you can look at it from an individual point of view as a file, or you can look at it as part of the file system. All right, so that's basically it as far as the lab. The last part of it is I want you to explore some forensic tools. So these are forensic tools. These are open source. So these are actually UNIX, let's say, open source tools for forensics, the sleuth kit and autopsy. So I suggest that you install them, load them, and then basically load victim SDA1 and see if you can gather some information about that partition. right? And that's it. All right, so that's the end of the description of this lab. So the lab is basically assigned, and I'm gonna give you guys starting Wednesday, March 25th, you have 1 week to complete the lab. Thank you.